Hello and welcome. My name is Shannon Kemp and I'm the Chief Digital Manager for Dataversity. We'd like to thank you for joining today's Dataversity webinar, Data Quality Strategies from Data Duckling to Successful Swan, the latest installment in a monthly series called Data Ed Online with Dr. Peter Aiken, brought to you in partnership with Data Blueprint. Due to a large number of people that attend these sessions, you will be muted during the webinar. If you'd like to chat with us or with each other, we certainly encourage you to do so. Just click the chat icon in the upper right-hand corner for that feature. For questions, we'll be collecting them via the Q&A in the bottom right-hand corner of your screen, or if you like to tweet, we encourage you to share highlights or questions via Twitter using hashtag DataEd. To answer the most commonly asked questions, as always, we will send a follow-up email to all registrants within 2 business days containing links to the slides. And yes, we are recording and will likewise send a link to the recording of this session, as well as any additional information requested throughout the webinar. Now let me introduce to you our speaker for today. Peter Aiken is an internationally recognized data management thought leader. Many of you already know him or have seen him at conferences worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions to the profession. Peter is also the founding director of Data Blueprint. He has written dozens of articles and books. The most recent is, what's the most recent book, Peter?
Data Strategy.
Ooh, it's a great one. Peter is experienced with more than 500 data management practices in 20 countries and consistently named as a top data management expert. Some of the most important and largest organizations in the world have sought out his and Data Blueprint's expertise. Peter has spent multi-year immersions with groups as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, and the Commonwealth of Virginia, and Walmart. Peter is joined, and Peter, so let me turn it over to you to get the presentation started. Hello and welcome.
Hi, Shannon. Good to be back here, and welcome to everybody. Thanks so much for joining us today. Topic today is data quality strategies. I'm not quite sure where the Data Duckling, Ugly Swan went from, but anyway, we'll dive on into the presentation in here. What we're going to look at today is, first of all, take a look at data quality in context of data management, because even though it's an interesting intellectual discussion, many people will argue that data management is a part of data quality, and others will argue that data quality is a part of data management. We see the latter, of course, and I wanted to show you how you put it in context there. I use an abbreviation in this particular webinar called data quality engineering, and it is important to understand that data quality must be approached as an engineering discipline in order to be effective. Hopefully the sense of that will come to you as you go through the presentation. We'll look at a data quality cycle and contextual complications, because there are some that are kind of important. We'll look at data quality causes and dimensions. We'll talk specifically about quality in the data life cycle, and we'll finish up at the top of the hour about data quality engineering tool sets, very different types of things that we're looking at. And we'll finish up, as always, with takeaway and, of course, some Q&A, which is the part of the show that Shannon and I both look forward to more than anything else. So let's get started. I live in rural Virginia, and this is a picture of my barn. Now, the reason I'm showing you this picture of the barn is to give you one particular set of constructs, which is the idea that the foundation has to be in place in order to actually do things. Now, those of you that don't know, I'm what's called a horse husband, and that means my wife likes horses as much as me, maybe even a little bit more sometimes, depending on what day it is. But she designed and built this barn on here, and when we got to this stage, the bank told us to stop. In other words, they gave us enough money to build the foundation, and the reason for that is because the bank understands that the foundation has to be strong and has to be inspected before you go forward. Because if we built a very good barn on top of a very weak foundation, instead of paying the bank back, we would in fact spend money on vet bills, and that's not the way the bank wants it to work, it's not the way my wife wants it to work, and it's certainly not the way I want it to work. So before construction could proceed, we had something called a foundation inspection. You get to this stage, somebody from the bank and the county comes out, double checks everything to make sure that the foundation is of sufficient quality before proceeding any further. The reason I show this to you is because there is no IT equivalent at this point in the vast majority of organizations. Now, this foundational stuff is critically important, mainly because most people remember Maslow from their high school. Maslow was the one that discovered we have a hierarchy of needs where each level provides enough to get going, but if you don't have that level done, you can't get to the second level. So starting out at the lowest level, if you have food, clothing, and shelter needs that are unmet, you have some physiological needs that are unmet. You will never become safe. If you are never safe, you will never become part of something bigger than you are. That's love and belonging. And if your love and belonging needs are unmet, then it's very unlikely you will develop self-esteem. If you don't have self-esteem, then you can't get to self-actualization. What does this have to do with data quality? Well, it turns out that most things that people want to do with data in general they fall into this thing I call the golden triangle up at the top. Getting ready to replace some of these buzzwords here, because we have, of course, brand new buzzwords that we keep looking at. That's the only thing I've changed in 30 years of doing this are the actual buzzwords. Blockchains going in, we'll cram some more things in there. Maybe MDM will come out or something like that. But those of us that are in data understand that that is really just the tip of the iceberg, and that these things have a very strong technological focus. The foundation that we need to have in data is illustrated below the line here at the part of the iceberg that's underwater that most people don't see. These are the foundational data management practices: governance, quality, strategy, architecture, and operations on that. And these represent organizational capabilities that, frankly, in our practice, we observe these to be more important than the things that are up at the top. Because while we'd like to do the things at the top, if we don't do the things at the bottom well, the things at the top will require longer time, more money, they will have less ability to deliver, and finally they will present greater risk to the organization than if instead we learn how to do this carefully. Now, if you'll watch the transition on this slide, the words governance, quality, strategy, architecture, data operations all move into another construct that we use a lot here called the CMMI Institute's DMM data maturity model. Again, in this case, what we're looking at is strategy is the ability to coherently manage your data. Most of your data is being managed very well at the work group level, but at the organizational level, the work groups themselves are uncoordinated, and consequently we end up with mixed practices that go out. We also have a class of data governance managers that are professional now that we can start to call upon to help us with these bits. In data quality, we want to make sure that the data is fit for purpose. We want to do this with the right technology and with the right processes around it. We, of course, also need some supporting processes in here as well. Now, the other reason for showing you the triangle in this chart here is because these well illustrate a concept that is the foundation can only be as strong as the weakest link. So that's a little illustration of paper clips in the lower left-hand corner there you see, and we have a paper clip that's weak. What does that mean in practical terms? Well, first of all, let's talk briefly about the scale. You get 1 point if you have a pulse. If your organization has repeatable practices, however, you get 2 points. If you document those procedures, you then get 3 points. If you measure the outputs of those various repeatable procedures, you get 4 points. And if you sit down periodically and come up with some new ideas around this, ways of improving the overall process, you get 5 points. So that's the general scale that we use when we're doing assessment of organizational practices. Lots of organizations have assessment methods, but my question to people when they ask me about using a different one instead of the DMM is, why would you want to use something different than a method that has been around for 20 years? It has an excellent academic track record, and it's also proven results that it has better ability to deliver improved practices than other assessment methods on this. Little commercial for the CMMI folks there, no problem. Point being here, though, let's pretend we've done an assessment here and that our data governance, our data strategy, our data operations, and our data platform and architecture come in at 3. Recall, again, 1 point for a pulse, 2 points for repeatable, 3 points for documented, 4 points for measurable, 5 points for optimized in order to go through with this. And what you notice here is that the weak link in the chain in this case is data quality. Now what that means is that we have to take the data quality and make it up to a 3 in this case, because trying to get a better strategy, better governance, architecture, operations are all going to be for naught, because this foundation is only as strong as the weakest link, and in this case the weakest link is clearly data quality. That's not always going to be the case. Your organizations will differ, but what I want to impart to you is the idea that if we don't get all of these things to the same level, they are only as strong as the weakest link. It's kind of like getting a D in high school and being called a D student for the rest of your life. It's unfair, but it does happen in cases. So let's move on a little bit further and talk about how this relates to the data management body of knowledge. Our DMBOK here is our first version that we saw, and the first version was good enough for us to criticize. It allowed us to think a little bit more clearly about the processes, because, of course, remember, all models are wrong, some models are useful, is the quote from George Box that we like to use in here. And this particular version of the model is missing two important concepts, the concepts of optionality and the concepts of dependency. That said, we still are able to look at this and see that data quality has a role to play. It's up there in the upper left-hand corner. I'll highlight that for you in a second, because, of course, we now have the DMBOK 2 that has been released, and again, we can see that governance is an important role, but really what we're going to be talking about here is quality. By the way, with the DMBOK, we did two things very badly in succession, so we weren't learning from our mistakes here at DAMA. We put data quality as the last chapter of the DMBOK list in the first version, and in the second version, shame on us. We should have done better with that. I tried to change it. For some reason, things were already in motion, so that's the way it goes. Now, the overview page for all of this talks about really what we're going to cover here in some amount of detail. There are some goals at the top. If you haven't seen this type of diagram before, it's called an input activity output or an input process output diagram. You can see the processes are in the middle. I'm not going to read you the 12 that are in the middle there, just like I'm not going to read you everything else that's on the slide. This is a good slide to come back and sort of get a handle on what's actually happening when we look at all of these things. We use this as kind of a summary slide here. Let's go on and talk a little bit more about how data quality and data governance fit together in context. First of all, we start with the upper left-hand corner because, after all, there has to be an organizational strategy. If we have no organizational strategy, then we have no ability to develop a data strategy underneath that organizational strategy. And the only point in having a data strategy is to delineate specifically what data is going to do to help the organization achieve its strategy. By the way, those of you that are in the nonprofit sector or in government or whatever, just substitute the word mission there for strategy, and all this stuff works equally as well. When we look at the relationship then between strategy and governance, we can see that data strategy is all about getting the data assets to do something specific in support of organizational strategy, which means that your data strategy needs to be expressed in terms of specific, tangible business goals. If we don't, we're just kind of waving our hands in the air, and that's not very helpful to anybody. Similarly, the feedback from data governance goes back and says, how well is the data strategy working? And the language of metadata is, the language of data governance is metadata. So again, if you're talking about something else during your data governance initiatives, that is going to be an issue. One of the things, many things, that data governance can do, though, is that it can talk specifically about how improvements to data quality can help data be better employed in support of data strategy, again, that employed in context of organizational strategy. And the last piece on this diagram here is that we need some evolutionary feedback about the current focus. Are we focusing in on the right specific things that are helpful to the organization? Again, if you don't know where you're going, any road will take you there. Therefore, nobody can say you're doing anything wrong in terms of what you're doing relative to anything else. So let's look a little further and talk about what does it mean to specifically define data quality. And I want to start out by defining data for you. Many of you are familiar with the joke that we use in a lot of these sessions, which is, what does the number 42 mean? The answer, for those of you that don't know, is that as always in well more than 1,000 talks that I've given around the world in the past 20 years, somebody in the room who has read The Hitchhiker's Guide to the Galaxy, wonderful little cute book of fiction, of course, that has a premise that the white mice and the dolphins are actually running the world with us as the experiment. Now, one of the subplots of that crazy little book is that the white mice and the dolphin decide they'd like to find out what the meaning of life is, so they create a gigantic supercomputer. It computes for 300 centuries and eventually comes back out and says, hey, the answer to life, the universe, and everything is 42. So I've just associated there a fact with a meaning. The fact is 42. The meaning is the meaning of life. I can give you an exact different interpretation of 42 as my age 16 years ago. Do any of you care? No, but it works the same way. The fact and the meaning says that Peter's probably allowed to buy adult beverages in the Commonwealth of Virginia. When we try to get from data to information then, we then build up another structure here, which is to say that information is differentiated from data in the sense that data is collections of things, but information are things that have been requested. So now we have an incentive there to actually answer those in there. And we go one step further in most cases and build up sort of intelligence, or we also call them knowledge and wisdom systems, depending on which decade we're in. But this now has to do with not just the requests, but also how the information is utilized. So those uses are very, very important. Now, the reason for showing this is because many organizations have invited me to come participate with them on different data improvement activities. And I have to tell a story of one, which was that I ended up very far from home, and I said, okay, what are we doing here? And they said, well, we tried to build a data system about 10 years ago, and it didn't work so well, so we gave up on it. Then we went to an information system. We tried to build one of those about 5 years ago, and that didn't work out so well either. So we want to skip the hard bits and go straight to getting our organization to be more intelligent. I hope you see the parallel here. Just like Maslow's hierarchy of needs, you cannot have intelligence if you don't have good information. If the data isn't any good, the information isn't any good either. So these are necessary and sufficient, necessary but insufficient prerequisites to getting all the way to business intelligence using this stuff properly. Again, I hope that's clear because it's a really, really useful analogy there. Let's look at some specific definitions here. Data quality, the definition that we use is data that is fit for purpose. It meets the requirements of the authors, the users, and the administrators, and we've been using that definition for quite a while. The reason is because it's very important to get this stuff correct. Let me give you a very specific story here, which is kind of fun. The U.S. Department of Statistics at one point in time made a data quality error when they were looking at leafy green vegetables. And the data quality error indicated that spinach was much more beneficial to humans than other types of leafy green vegetables. Turns out that is an absolute data quality error. There's nothing more healthy about spinach than any other leafy green vegetables, of which we should all eat lots on here, but the mythical powers that it gave Popeye were just simply the result of a data quality error. Data quality is often synonymous with information quality because, again, it's easier to manage them together than it is to try and manage them separate. So there's lots of things that happen here. Again, if you were trying to find out what particular size, set of vitamins that you wanted to get, you're probably better off with a vitamin than you are with a can of spinach. Although, don't let me get the spinach people mad at us. We like spinach as well. So if we've got that as data quality, let's look at data management. Data quality management. It's the idea of planning and controlling and implementing activities that measure, assess, improve data quality. We'll run it through some life cycles in just a little bit as we go through here. It does entail, though, the establishment and deployment of roles and responsibilities concerning the acquisition, maintenance, dissemination of data all the way around. And it's critical to have supporting processes include change management, continuous process for defining data levels all the way around. So let's go one more definition. Data quality engineering is recognition that data quality solutions cannot be managed but must be engineered. There are lots of things about engineering that are never taught anybody in college and university, particularly around the area of data pieces, and that the engineering focus on this is really an important distinction. Engineering concepts are just generally not known well. Let me give you a very specific example on this. This is a project that we were on for the Defense Logistics Agency. It's a little bit old, but not at the same time improper to describe here. By the way, there's lots of very detailed papers on this. If you need to get to them, just give me a shout or look them up on the web that describe all of these. The challenge here was that we had millions of NSNs or SKUs that were maintained in a catalog, about 2 million of them, and that the data keys, however, had become distorted so that the knowledge workers who were using this data were forced to rely on looking at this information in clear text or comments fields. So the original approach was supposed to be a manual extraction process. We need somebody in to go pull this stuff out and do it by hand. The proper engineering approach is to look at a balance between application of engineering concepts and manual concepts. So we developed what would today be called text analytics to convert the non-tabular data into tabular data. By the way, I like those terms a whole lot better than I like structured and unstructured. But it was kind of fun because we saved the customer, in this case, well over $5 million, but more importantly, it was the first time I had actually gotten to a person century of work, which I thought was kind of a nice piece on that. So let's just take a quick look at how it went. When we were doing the work here, this was a team of 2 data engineers who were working for 20 hours a week on the project, or 1 FTE per week of the project. So we're holding the left-hand side of the equation fixed on that. And you can see that the very first time we did this, we kind of didn't do too good. Now, this also speaks to expectations management. We'll get to that in just a little bit as well. But by the time we'd gotten to week 4, we'd actually gotten up to 55% of the problem solved, and that was kind of nice. We'd also determined that out of the data in this pile of data, there was 12% of it that was completely ignorable, just absolute rubbish. And therefore, our unmatched items were fluctuating up and down depending on where we were going. Now, the way we were doing this, we were going in and asking their subject matter experts if column 7 contains an asterisk on Thursdays for this type of part number, what are the right procedures to take in order to do this? Very detailed, very tedious kind of work. When we got to week 14, however, we were clearly able to see that we had gotten down to a large value here, in the sense that only 10% of the items were unmatched. At that point, actually, it was 91% were unmatched. Of that, 22% were just pure rubbish, and you can see that number was completely leveled off, so we were very comfortable saying that 1/5 of your data was absolutely worthless. And then, of course, we have matched items running from 68%. And they actually asked us to get one more piece. They said it would be really great if you could go and get this one other piece of data, which brought us up to a nice round number of 70%. We've solved the problem. The rest of the 22% was rubbish here. And what that meant was that the original problem had been 2 million NSNs, and we had now brought it down to 150,000. I don't know about any of you, but I would certainly rather work on 150,000 things manually than 2 million manually. We also were able to achieve some very significant results. One of the other things that's very interesting about this whole topic of data quality is that many people say you can't quantify it. Well, I respectfully disagree. Here is 92.6 person years that would have been devoted to doing this if we had given them, again, 48 hours a day, 5 days a week, 7.5 hours a day, blah, 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 blah. Put a number on there at $60,000 per worker, and there's my person century of 93 person years. Of course, the most important number on this chart is the number 5 minutes, because it's probably not the right number on this. So now I put in the savings that I've gotten on this, and I'm just changing the numbers that are saved. Instead of 7 person years, we now get down to a very small amount of money, $420,000 instead of $5.5 million. So there's my $5 million savings. And oh, by the way, I mentioned 5 minutes before. Does anybody think they can actually solve that problem in 5 minutes? The answer is, of course, no. So that's a necessary but insufficient amount of cost that you'll spend in order to do this. There are some problems with data quality, though. It's just a very broadly misunderstood discipline outside of IT and outside of the business people that spend time with it. Most people think that you can fix the data quality has been taken care of by IT, that all the problem is in the source, that the data warehouse will provide you a single version of the truth or the new system. And again, standardization will eliminate these things. These are true to a degree, but they don't just happen. The real problem with data quality is that data quality looks different to different people. So I like the story of the blind men and the elephant here describing it. Somebody else picks up the tusk and they say it's a spear, and somebody else picks up the ear and says, no, no, it's a fan, right? Well, it does look different ways to different people, because most organizations approach data quality in the same way that blind people approach the elephant. They tend to see only what's in front of them. This leads to confusion, which means our data quality engineering solution is required to help develop a more complete picture and facilitate cross-boundary perspectives on this. Again, our definition for quality data, data that is fit for purpose. Make it very simple. Let's make sure everybody understands that some things are meant to do some things. That red peg is not going to fit into that particular hole, which means we can objectively say that that data either passes or fails for the fit for purpose that we're trying to get it to work. This is a book I wrote a long time ago with my co-author Clive Finkelstein, and again, real pleasure to work with him over the years. And we put some words in here that said, you know, why haven't more organizations taken a more proactive approach? And the answer was kind of interesting to us. First of all, fixing data quality problems is not easy. It might be dangerous. You might make things worse because your efforts are likely to be misunderstood. And oh, by the way, since you raised the issue, now you get to determine whether it's fixed or not. So a single data quality issue can grow into a very significant and unexpected investment in order to do this. Let's look specifically now at the life cycle around this. And again, those of you that have heard me before know I have some grumbles. Here's one of my pet grumbles. You'll see this wonderful article out there in a website or a pretty good publication that says 4 ways to make your data sparkle. 1, prioritize the task. 2, involve the data owners. 3, keep future data clean. And 4, align your staff with business. Well, I'm sorry, this is just not really very helpful here, and we really do need to get a little bit more specific about it. Let's dive down and take a look. What I prefer to do is say, let's take a structured approach to data quality engineering, which allows the form of the problem to guide the form of the problem, provides a way of decomposing the problem into smaller bite-sized chunks, just like how do you eat an elephant, 1 bite at a time, feature a variety of tools for simplifying system understanding, a series of strategies for evolving a design solution, and provide criteria for evaluating the quality of the various proposed solutions. Plus, of course, we want the organization itself to get smarter. So let's operationalize that a little bit and talk about the data quality engineering cycle. Some people know this as the Deming cycle, which is a very appropriate metaphor for it since he's sort of the father of our data quality movement around. The idea behind this is plan, do, study, act, or plan, do, check, act in order to do this. And again, we're identifying, defining, checking, identifying, and seeing what's happening there. So let's look at planning. All right, the key there is we need to look at how big the issue is, what is the time frame in which we need it solved, what is the cost and the impact, and evaluate a number of alternatives for addressing that particular solution. Then you need to deploy a solution. Sometimes it may involve something like data profiling. We'll talk about that in just a little bit. But the idea is we're going to fix the areas that are root cause for all of this. We need to monitor the cycle to see if it's done what we think it's going to do, and then act appropriately. If there are more unmet issues, we need to go back and meet those issues. We need to go back and fix them, and a new cycle comes in as soon as we start this process over again. So not many shortcuts in this. We simply have to be able to go in and really identify these things with rigor. But one of the misconceptions that you'll see around this is that some rules will be implemented so that no data, we've seen a lot of organizations that say no data can be corrected unless the source of the error has been discovered and addressed. Well, there's not many businesses that run on that kind of a time schedule that will let us do this. And I think we all agree that we'd like to go upstream and correct the source of the data quality problems rather than trying to fix it after it's already polluted the lake at this point. But does all data need to be 100% perfect? And the answer is no. We apply Pareto analysis, which is our 80-20 rule. Not all data is of equal importance. Depending on what you're doing, we need to have scientific, economic, social, practical knowledge to come in and help us understand what's going wrong and be able to take it from there. So let's take a look now at the causes and dimensions that we have. There are 2 distinct types of activities to support data quality. Data quality practices depend on practice-oriented activities, and at the same time they depend on structure-oriented activities. Very clear that you need to have both of those in place in order to produce data quality. Let's take a look at each. Practice-oriented stems from a failure to rigorously capture and manipulate data. Again, perhaps you are edit masking, perhaps you are range checking the input data, CRC checking transmitted data, hash totals. Again, if you're looking at blockchain at all, this is one of the key tenets to make sure that blockchaining actually works. So examples of poorly followed practice-oriented activities would be allowing imprecise or incorrect data to be collected when the requirements specify otherwise, or even something as simple as presenting the data out of sequence given a set of things. Typically, these are diagnosed in a bottom-up manner where we find and fix the resulting problem, but they can be addressed by implementing more rigorous data handling and governance around this. A specific example of practice-oriented activities causing a data quality problem is a favorite story that I like to tell, where I was at a hospital organization, a healthcare organization, and the director of the hospital made an announcement that they were going to have, they had done so much good knee surgery here that the hospital was going to be diving into knee surgery in a big way and become a knee surgery capital center of expertise. The problem was, it turned out that the associates at the hospital weren't actually doing as much knee surgery as the director of the hospital thought, but they all knew that the default admission code for the hospital, being knee surgery, was not very well maintained by the professionals that were checking people into the hospital, because they were oriented to get the people in the hospital quickly. And so they didn't bother, they simply took the default. So here we had a situation of a very well-meaning executive who thought they were making decisions based on good quality data, and in fact discovering that if they had corrected their data inputs, they would have discovered they weren't doing nearly as much knee surgery as they thought they were doing. So that's an example of practice-oriented activities. To look at structure-oriented activities, these are really very different. They occur because the data and the metadata has been arranged imperfectly. The data might be in the system, but we can't access it. You might have a correct version provided in response to the wrong query, or as a wrong response to the query, and data simply not being available. And the reason for that is because developers tend to focus within system boundaries, whereas data tends to move across system boundaries. So these affect both data model quality and data architecture quality, and if they don't work, you have a very big challenge. By the way, one of our best practices that we're considering now is that organizations should always request a copy of the data model whenever somebody is going to provide you with software that they built or that they're selling to you in any way or form, because that way you can check to see if the structure of that data model and for the software that you're purchasing complements or contrasts with the way in which you do your data practicing, essentially. These are typically done in a top-down manner, fix the root causes in this case, but we don't tend to discover these quality errors until it's too late. So again, quality of the data models, quality of the architecture. Let me give you just a very quick example on that as well. New York City has a big tree problem. They actually used to title this article Big Data, but it's not anything to do with big data. But New York City has 2.5 million trees. And in just one 11-month period between 2009 and 2010, 4 people were killed just in Central Park alone by falling tree limbs. Who knew Central Park was so dangerous? But we've had 3 hurricanes already this year, so we should pay attention to that. Anyway, the arborists that were on staff believed that pruning the trees could help make them healthier and more likely to withstand a storm, decreasing the likelihood of storm damage. But they haven't had any data until recently to bring it up. So they did ask the question, does pruning trees in a year reduce the number of hazardous tree conditions in the following year? They had lots and lots of data, but they had some real structural challenges on this because the pruning data was recorded block by block, but the cleanup data was recorded at the address level. And funny enough, trees don't come with primary keys. Not having these unique identifiers, they had a lot of data munging to do to get this downloaded, cleaned, merged, analyzed, and very intensive modeling. After doing the work, which was fairly expensive, they did discover that pruning trees for certain types of hazards caused a 22% reduction in the number of times the emergency department had to send a crew out for cleanup. But just like all of this, anything that's a analytic type or BI type exercise, usually the best answer is that it generates more questions. So New York City can't prune every block every year, so they're now building block risk profiles, but only after they've completely changed the structural aspects of this. So again, just very briefly, data quality depends on 4 dimensions. The quality of the data value, the representation of the data, those are practice-related dimensions, and the quality of the models and the quality of the architecture, those are structural dimensions. Again, practice-oriented value representation, structure-oriented model, and architecture in there. I'm going fast. These are reference slides for you. I also have some slides at the end that have some more reference material on these specific topics, which is to say that if we look at the relationship between those 4 attributes, quality, representation quality, value quality, model quality, and architecture quality, you can see that on the left-hand side of this picture, you are closer to the user, what the user sees. And if you're at the right-hand side of this picture, you have closer to the architect, less visibility into this as well. I'm going to show another version of this same chart here. This has now all of the data quality attributes full on this. And you'll also see I've included some notation here. One data architecture on the right spawns multiple models. Each model spawns multiple data values, and each data value spawns multiple ways in which that data value can be represented. Remember, the representation and value pieces are the ones closest to the user, so they are more likely to be the focus of data quality efforts, not through any bad reason, but because that's the most obvious place. However, if you were trying to fix things and get some leverage on this, you need to go back and examine the structural aspects of your data quality challenges as well, because if you fix something at the model level, you will fix many things at the value and representation level. If you fix things at the architecture level, you'll include model quality in it as well. But most people only fix what they see, which are the things over on the left. And that's kind of like being told you have a data quality problem here at the bottom of Niagara Falls, and you're in that little boat that you see on the right-hand side of your screen, and you're being told to fix the water quality problem here from the boat. There's just no way that's going to happen, and we're probably not ever likely to see the falls freeze again. So you can't wait for that particular outcome either. Again, causes and dimensions, very, very clear. Most importantly here, when somebody starts working with you on this, don't let them go out and say, we need to define this stuff. This is well defined in academic literature, and it's well accepted as best practices on this. So make sure that whoever you've got working with you on this conforms to this type of an activity here. Go a little bit further now and talk about quality and the data lifecycle. Our good friend Tom Redman, Data Doc, many of you know him, wonderful person, was the first person to actually describe what this looked like. And we're very thankful that he did this, because if he hadn't done it, it would have just required somebody else to get to it. So while he looks here and says data comes in through acquisition cycles and then we store it and then we use it, we all recognize now that this was a good first attempt, just like the DIMBOK was a good first attempt on this. And that now what we're trying to do is to look a little bit more closely. The proper data lifecycle model goes like this. Until you have metadata, you can't have data. So we create metadata, and then we may structure metadata. The things that are in writing there are the products that flow. Again, from metadata structuring, then we can create the data. We populate the data models and the storage locations that are there. Once we've created the data, we can store the data values. The data can be utilized. The data may be manipulated. The data may be restored back into the storage system. Sometimes we evaluate the data, looking at it from an assessed perspective. Sometimes that assessment can cause us to go back and manipulate the data. The data values get moved around. Sometimes we may refine the data. We were working with a group recently that had lost a bunch of data because of rounding errors, and we had to go back and find where they had been rounded. We were able to provide the cost of that rounding and show that that was not a shortcut. It was, in fact, a long cut for people to get that. But here's where it really gets interesting. If you have structural defects, it means you need to go back up and refine your metadata. If you do not, you will spend all of your time correcting the structural data quality problems that need to be addressed in a different fashion. Only when I understand those model refinements can I restructure the metadata or create new metadata in order to come up with this. And you can see this model is a little bit more detailed than the standard model. Let's look now at the same thing, but now I'm going to show you what the focus of each of the efforts are. Again, when we look at it from this perspective here, you've got data architecture quality, data model quality, you've got the value quality, the representation quality in different parts. And there are some matrices here that we can pull in place. They're not in this particular presentation, that say these data quality approaches are going to solve these data quality type of challenges that we have. So again, very important that you understand all of this as you're looking to help improve the quality of your data. Many people don't like the fact that I didn't put it in a circle. It's just a bunch of square boxes, so I redid it this way to come up with a circle. I'm not sure it's a better representation. I do think the information is all out there. This is somewhere where you guys can give us some feedback and say, what do you think about the whole process? If you'll notice on this chart, same chart as I showed you the other one, the starting point for a new system is in the upper left-hand corner. The starting point for an existing system, however, is the data assessment process, which is the bottom right-hand corner. And I made this one go counterclockwise. It drives people crazy. I'm not sure if I can fix that, but anyway, I think you can get the picture here. It's not a trivial process, and it certainly is more involved than usage and acquisition cycles. Let's talk a little bit now about data quality tools. And there are lots and lots of data quality tools. It is the last place that you want to start, however, because if you don't have a good diagnosis of what your problem is, any tool will get you there. And there are lots of very good tools out there. In fact, some that you don't even have to buy, where you have lots and lots of people that can do SQL Server queries and other things in order to come up with the various bits and pieces that we're trying to talk. So when we look at this, we're really looking at two different approaches, a bottom-up or a top-down. We've already talked about them a little bit. The bottom-up assessment is specific inspection and evaluation of specific data sets. Nothing wrong with that. It gives you potential issues based on the application, the broadest possible application of automated or more likely semi-automated procedures here. Top-down, however, requires the business users to engage. We may document their business practices, understand critical dependencies, how their processes consume data, and which data elements are critical to the success of those applications. When I have this information, I can then start to define specific measures. The process for defining, excuse me, hang on. Sorry about that. The process for defining the data quality measures then is to select one of the specific impacts and evaluate whether the dependent data elements create, update, read processes that are associated with that specific impact, listing any requirements that are there, and then making sure those are actually followed. Specify the associated dimension of data quality and the business rules that will be likely used to determine conformance to the expectations. Again, remember, it's either fit for purpose or it's not. And then describe the process for measuring the conformance with a specific acceptability threshold. Many times these translate into service level agreements that you'll have. I had one organization that I was working with. It was a lot of fun. It was basically a catalog organization, and the group had outsourced its ability to provide new customers in through catalogs to a third party. But the interesting part was they had not specified a service level agreement. So basically they got paid for sending names and addresses over to this company, and nobody was even bothering to double check whether they were sending the same or even accurate addresses over. Again, service level agreements are going to be critical to this. To some of you, that's no problem. To others of you, that's kind of new stuff. See, these service level agreements give you the ability then, the targets, to do the data quality inspection and monitoring that you're going to do. So you can look at different things, and you're seeing here, these are three levels of service that you can have, which is, I guess if you lose something, it takes 7 to 8 days on step one, whereas if you're in the premium service, you get it the same day. So if you need it faster than 7 or 8 days, you pay more for it as far as going forward there. Again, what are the data elements covered by the agreement? What are the business impact of flawed data? What dimensions are associated with each specific data element as it relates to the process? What are the expectations for each data element that are there? And what are the measurements against those particular expectations? Once you have the ability to measure, monitor, and manage these data quality pieces, you can now start to look at batch or in-stream collections and look at specific granularities. Again, are we looking at this at the data element value? Are we looking at the data record? Or are we looking at the data set side? All of these are critical and help you to scope the specific data quality engineering tasks that you're facing in this. Talk about a couple of categories of tools which basically help you analyze, cleanse, enhance, and monitor these tools. I'm going to go through them. They're the ones on the right. First one is data profiling. Data profiling, interestingly enough, people keep discovering this, which is really kind of a nice thing. The impetus for doing data profiling came from a piece of research that we funded out of the Defense Department when I was there in the late 80s, early 90s. A woman named Dina Bitten, who I've never actually met, would love to at some point. I understand she's still active in the field, but she's not on LinkedIn, so I can't find her. Actually came up with a series of algorithms for the Defense Department that have since become embedded in your standard data quality, data profiling tools. It's an idea of the assessment of the value distribution and the clustering of those values into domains, which gives us the ability to distinguish between good and bad data before making any specific improvements. One of the things we talk about data profiling is kind of like taking an X-ray of your data. So it gives us a series of algorithms that allows us to determine how much variance in the data quality exists within the data set, and then also across data sets. The more you read into these tools, the smarter, in quotes, they become. And this smartness allows you then to start recognizing, hey, I just read in here a data set with employee information into it, and it turns out the employee data looks an awful lot like the shipped by data in another data set over in logistics. If those are the same, we ought to define them as a synonym, and more importantly, treat both of those data sets with the same application of data quality tools. In fact, profiling is so powerful, we can build a logical third normal form of any piles of data out there if you read them into this and follow the procedures. So it allows us to go in and look at prescriptive rules, even very simple things like notifying the help desk that changes are about to come in, or the business analyst guiding their day-to-day kind of work on all this. The process here allows you to come up with these data flow diagrams and see what's actually happening every way that you go through that. There's a couple of really great companies that are out there doing this sort of work. If you want to do that, we can ask some questions a little bit later on. There are different ways of approaching quality, but all of them are going to be helpful to you. Really key to this is to pick sort of one of these tools and get used to it, but you don't even have to do that. Our advice to organizations is that they can actually do an awful lot with structured query language and a good series of programmers and insight into the data models that you have. And once you've done that for a bit, the only thing the structured query language can't do is get smarter as it goes through and understands the data. So if you learn how to do sort of the tools, it's kind of like the old days where they used to make you do the calculations before they'd let you use a calculator. Same thing here. If you learn how to do this profiling, and again, there's a couple chapters in the book that'll help you do this, then you'll learn which tools are better suited for you. So always, with all of these tools, try it on your own, try to build something on your own before you go out and spend lots and lots of money on this so that you can have a good conversation with the vendors. And we recommend that in any form of major investments in data, whether you're doing master data management, data quality, governance, et cetera, et cetera. Our second tool set then is parsing and standardization tools. And these parsing tools were some of the ones that I described back during that DLA example. One of the groups in the United States that does a great job of standardizing things is the post office. And you'll notice that if you're ordering things online in today's environment, many of the service providers will go out and take the address that you type in, send it off to the post office, get it normalized according to their standard definition, and pops it back up and says, hey, I know you put in this over here on the left-hand side. Is it okay if we just take all of these things to, this sort of normalized definition here? And you're also helping, of course, train that data set as well. So again, very, very useful set of technologies here. Another one is a data transformation. Sometimes we call these business rule engines, where inputs cause specific outputs. If you think about it, most of your programs that you have out there take data in one side and different data comes out the other side. If it's just transforming it, you may find under many circumstances in today's environment that a rules engine is a lot easier to maintain than a pile of spaghetti code with a bunch of values that are in it. This is absolutely huge, and yet most people are reluctant to get rid of old programs because they kind of trust the old program. So once you've proven that the business rule engine can do as good, and that's not a better job of transforming the data, then it does make sense to look at replacing specific programs in your legacy environment, getting rid of lines of code and improving your data quality at the same time. Very nice win-win with that set of tool techniques. Identity resolution, another key thing. We've got to be able to find out that this person over here is in fact that person over there. There are two basic approaches to this. Again, it's central to anything that happens, and particularly true when you're looking at big data technologies, because that's one of the things that you're trying to find out is what are the patterns that are out there. So deterministic approaches rely on patterns and rules, assigning rates that give you predictable results, but it's dependent on the rule developers and the applications that are set up for it. Probabilistic matching then relies on statistical techniques, and I'm reminded of a case that we did for Radio Shack a number of years ago. It was a really fun exercise. Radio Shack, just like most organizations, would like to sell something to everybody that has something in their shopping cart. In the fast food industry, it's called, do you want fries with that hamburger? Now, McDonald's and the rest of the fast food places know that if you just order a hamburger, you probably forgot to order fries, so their customer service reps are trained to ask, do you want fries with that? Because the answer is very often yes, which results in much more profit for them being able to do that. Radio Shack wanted to do the same kind of thing here, and what they were doing was they wanted to sell batteries with everything they sell, because Radio Shack sold a lot of electronic tools. Now these the electronic tools, the toys that they sold at Radio Shack, the tools that they sold, each of them used batteries in different way, and Radio Shack thought they could just go through their 30 million items in their catalog and look for anything with the word battery in it. Turned out it wasn't nearly that easy. Many things that are described as a battery do not come with the word battery in them, and many things that are not batteries have the word battery in their description as well. So we had to develop a measure of batteryness. In other words, how probable was something that it was actually a battery. And once again, we used the same approach as I did when I was telling you the DLA story. What was happening here was that we found things that were definitely batteries, a lot of them, and we found a lot of things that were definitely not batteries. And it turned out we had a little bit left over, it was about 15,000 items out of the 30 million that were not determinable. We couldn't do a specific thing, but they were all assigned a measure of batteryness. And what Radio Shack did in those days was that when they had extra time, money, interns, you know, sort of a surplus capacity type of thing, they would put people to work on this 15,000 items that we had, chipping away at the list little by little based on the measure of batteryness to guide them priority-wise in order to move through this. Oops, sorry, I went too far. Fifth one, enhancement. This is the idea of going in and enhancing the data. So again, we may have a specific piece of data. My age, for example, again, 16 years ago was 42, right? Well, we might also want to tell when that was done, the time and date stamp. We might want to say the information's been audited, it's been approved. It may be enhanced with GIS information, demographic, psychographic information. One of the bits of enhancement that has been happening that many of you may have seen is that some of the credit card companies have now developed geolocations for where your credit card transaction takes place. They're finding this is very helpful in cutting down on the number of protested charge items. So, for example, if you see a charge item on there and you say, I didn't go to a Starbucks on that day, you know, therefore I'm going to protest the charge that's on there, you can click on your bill and the bill will actually go to Google Maps and bring up a picture of that Starbucks, which they're finding in many cases jogs people's memory and say, oh yeah, that's right, I was there. I don't have to protest that. Notice no customer service representative has gotten involved at all. A very nice use of quality enhancement tools around that. Our sixth set here then is just reporting, and reporting has been around forever and ever since Crystal Reports, since before Crystal Reports, if you remember all of this. Crystal Reports, of course, was the answer to everything for a long time. But good report writers can do a really wonderful job at helping to improve quality. Again, I'll flip back over to Tom Redmond's pieces. Tom has a technique that he likes to use for reporting that he calls his top 10, and we've used this very successfully on a number of clients where they say, I don't think we've got any problems with my data. And we say, great, go grab for us the customer information for your top 10 customers. When you look specifically at those top 10 customers, you'll find in many cases it's not as clean as you want. If you say, these are the problems we found from a 10-minute operation looking at our top 10 customers, maybe there is something here we ought to get a little bit more into in order to see what's going on here. So we're getting close to the top of the hour here. Let's go a little bit closer to some takeaways and some Q&A coming up on it, so hopefully you guys will have some questions for us doing this. Guiding principles right out of the DMBOK and other sources. Data needs to be managed as a core organizational asset. Eventually, you need to find where is the best record for the data elements that are out there. This is particularly important because many organizations have many different sources. Our favorite statistic on this is that the average organization has their data on customers in 17 different databases. Now, the problem with that, of course, is that, first of all, how do you keep all 17 in synchronization, and perhaps more importantly, why would you want your people having to think about that process anyway? We really should have a master source, a gold source that's there. Data elements, we'd like to standardize all of them, but it never works out as well as all that. We'd love to leverage governance in this area, because governance is the kind of thing that says, look, I know you think you've gotten behind on the IT project and you just want to forklift the data into that new data warehouse that you've got standing over there in the corner that's empty, but it's really the worst thing that you can do, and a governance organization is really, really helpful in that process. You want to leverage data governance to help control that. You want to use industry and international standards where it's applicable. You need to make sure that downstream data consumers understand what their expectations are and can specify them so that people upstream can do a good job on that. Look at specific business rules. Don't keep it in somebody's head, but let's formalize these so that we can, in fact, manage them programmatically. That understanding the importance of validating various data sets is really critical, that business owners have to understand and agree by the data quality SLAs that are put in place, that we apply standards to the original source as opposed to the something that's 2 or 3 generations away from it. And if it's not possible to correct the data at the source, then to find the organization pieces that will allow us to do this correctly. Influence the data to the data brokers to local requirements may be limited. We've all seen in the Equifax mess that's been going on for the last couple of weeks here, our ability to influence them is limited until Congress decides to step in and say, oh, by the way, you guys should apply some good practices around that as well. By the way, I would say the Equifax issue was a huge data quality problem. You may remember that their CEO was testifying in front of Congress last week, and he blamed it all on a single IT person. Well, if your organization allows itself to be dependent on a single IT person, that's an organizational data quality failure. And I can tell you, there were checks inside of Equifax that were missed as well. So throwing one IT person under the bus does not actually help your stuff. Finally, last one of these, we want to look at these measures so that we start to gain understanding of what we're using. Unfortunately, many of your organizations right now can say all of our data in our organization is of unknown quality. And that's a really scary statement, so be careful when you say that. Don't say it in front of Congress. Certainly don't want to say it when the auditors are around. But if your organization is in that situation, just basic reporting is a great way to start trying to come back and address some of these issues. Again, the Equifax issue was a horrible situation. We've got a lot of others that are out there. Once again, my favorite example of this, many of you have heard me relate this as well, is the combination of the Office of Personnel Management data, which has information on persons given a position of trust by the United States government. And that list is out there now, along with some fingerprint data and other things. Not very good. We don't want that to be in the hands of the bad guys, but it apparently is. Then we add to that the Ashley Madison oopsie. If you don't know what Ashley Madison is, consider yourself very fortunate. Ashley Madison was a dating site for married people, so I'll let you take it from there. 1/4 of the population of Ottawa, Canada, which is their version of Washington, D.C., actually were in that database. So Canada's having a little bit more fun than we kind of suspected them of, perhaps, in that. But now we can take the people with the position of trust in the U.S. government, and we can now get which of those people with a high level of security clearance also were silly enough to get on Ashley Madison and register using their .gov, .mil, .vatican, yes, there were some from the Vatican, email addresses. So now they are subject to blackmail, and because they're subject to blackmail, we can then go to the target data breach and grab the information from the target data breach to find out about their buying habits and whether or not they are buying, for example, buying gifts for people who are pregnant that may be not in their marriage. So this really represents what Congress has called the biggest threat to national security that we ever have. We're not sure people yet get that that's a data quality problem, but it surely is. So finish up, Our goal here is to measurably improve the quality of data with respect to business expectations, to define the specifications for integrating data quality within the system development lifecycle system, and to provide defined processes for measuring, reporting acceptable levels of data quality. Here's our summary chart. And we're right at the top of the hour, so I'm going to put our upcoming event slide, but I also want to tell you that we've included in here some references, additional reading, data quality dimensions, other things. And Shannon, we are at the top of the hour. Back over to you.
Peter, thank you so much for another fantastic presentation on one of just the core topics that's so important to everything we do in data management. Just to answer the most commonly asked questions, we've got a lot of good questions coming in, so if you have additional questions, feel free to submit them in the Q&A in the bottom right-hand corner of your screen. And to answer the most commonly asked questions, just a reminder, I will be sending a follow-up email by end of day Thursday with links to the slides and links to the recording and anything else requested throughout the webinar. Now, the first point we have coming in here, Peter, is really more of a statement than a question, but maybe you have something to add to it. We find many errors are introduced at time of load by our staff into our data warehouse. These errors are easier for us to identify and correct. As a data repository, we are unable to correct the data that is incorrect from the source.
Can you say the first part of the question? I missed a word, started with L.
Yes, as we find many errors are introduced at the time of load by our staff.
Load, there we go. Thank you. Okay. So really, that's a great diagnostic, and if you've got that kind of knowledge, it tells you where on this process you should be looking. So I'm going to flip back up to our input chart here. Take it a second to build, but we're not metadata creating at that point in time, right? We are not metadata structuring. What we are doing there is data creation. So we're loading the system through data. We're populating the data models and the storage locations. That type of an approach to data quality is very different from other phases of the cycle, which is why I built this particular chart here. When you have people loading the data into the data warehouse, there are two things that you can do to help you address this. Again, they fall into the structural versus the procedural errors. The structural error is to make certain that the organizational data warehouse has the right type of controls in place. So, for example, that you can't add a transaction that doesn't have a corresponding master data. I was in Boston last week working with a great individual who spends a lot of time trying to get projects going for this particular company. And you can't start a project until you have a budget code, a charge code for it. And if the charge code application form isn't filled out correctly, then this person can't add that information to their SAP system in this case, and then they can't get the project started. And they all said, well, how's that a data quality problem? I said, well, your project's all ready to go, but because somebody forgot to do something procedurally in this, you now have a structuring problem of I want to start applying transactions to a non-existent project. So take a look at this chart as you're looking at your organizational challenges that you have and say, what part of this do I need to use to get started? Because not all of it is relevant always. By being able to focus in on a specific area here, it will limit the number of things you need to consider and help you identify causes to your data and, more importantly, solutions to your data quality problems much, much faster. Great question. Thanks, Shannon.
Absolutely. And, you know, kind of adding on to that, a big part of what I do is document technical processes and requirements in terms that end users, managers, and leadership can effectively, easily understand. When it comes to data quality requirements, what are your top tips for communication and language?
Stories, stories, and stories. It's fine to talk about this type of a geeky diagram among us data people, but can you imagine trying to explain this to an executive in an elevator pitch? You know, it just doesn't work. So you have to take what's going on in your organization and highlight the fact that this data quality problem means that this business outcome isn't going to be achieved or will be less achievable because of what we've done. So I know that sounds trite to say stories, stories, and stories, but if you've got somebody in your organization who's a gifted storyteller, get everybody on board with these stories. I had a really wonderful experience with a company that tried to do too much around the time they were trying to sell lots of chocolate. So I don't want to give away too much of the information here, but most organizations, when they are selling at peak times of the year, they will lock down their IT resources and not change things so they don't mess up their ability to get chocolate to people that want to buy it. And they didn't. They tried to do too much complexity at once and literally ended up with 5 million pounds of chocolate that went not delivered to customers that wanted to pay for it, and that was a pretty heavy hit. So what we did is we made sure that everybody in the entire organization understood the chocolate story. And I'm going to pound my fist here on the table here, so brace yourself. But we are not going to do the thing that happened last time, the chocolate story. And even now when I go back in and talk to these guys, and I'll start to talk to them about some things, somebody at the table will go, oh, you mean the chocolate story? We learned that lesson already, so we don't have to have that in there. So I know it's a very glib answer to say stories, but it's no good to tell them that the data value doesn't mean anything if they don't know what the effect of that data value being incorrect has on the organization. I'll give you one specific example also on this beyond the chocolate story, which is that one of the groups we work with is a charitable organization that helps organizations get resources. And this organization was able to go back in and say, look, you guys, they were collecting data from the workers in the organization. And they said, if you guys had if we had used the data in its raw form the way you gave it to us, we would have built something completely incorrect here, which wouldn't have helped our constituents. So you've got to be able to take this to the next step and have it tie directly into some sort of outcomes along the way. If you don't, you will be unable to, in fact, get people to understand the importance of data quality around this particular topic. Again, great question. Thank you, Shannon. That was really good.
Yeah, so and another, just more of a statement coming in for you, but maybe you have something to add to it. We have started by validating our TIN masking. We have also automated the process of identifying all of our TIN and actually properly masked.
So it sounds to me like the TIN might be a master data element in your organization, something that's worth managing. We did not talk about the intersection between data quality and master data management. If I'm not right on that, forgive me for answering the wrong question, but what we're really trying to do is to say, if I've got the TINs right, then a lot of other things become easier. We're never going to say it's easy, but we'll definitely, accept easier. Whereas if you've got, 10 or so different places where TIN needs to be updated around the organization, it's going to be much harder to do that. You may fix one pile and then discover it gets wiped out by a batch job that comes along and puts another copy of the data out there that you didn't even know about. It's really critical to understand the whole import of everything that's happening here, getting a holistic picture, and allowing the organization to look and say, within this cycle, where are we and what types of things can we apply to given them.
So what's a good thing to read about the data profiling method? What are some good resources for that?
I will call out one of my books, but that's got a couple of chapters on it in here, but really the best book to go for profiling is written by our colleague Jack Olson. And give me a quick second, I'll look it up. My book is Building Corporate Portals with XML, which sounds sort of bizarre for a data quality book, but we had some really good data quality in there. Because, of course, again, go back to the statement I made earlier, many organizations can say that all of our data is of unknown quality, and that's simply not something we really want to get out on the street on that. If you can identify specific items that are quality, then what we were advocating here was to go and pull them into a portal or to brand the data. So then we would use data of only known quality. Give me a quick second, let me look up Jack Olson in books here, and his book is, where is it? Well, there's 10 million Jack Olsons in here. I think it's called The Value Dimension. Hang on, let's see.
And if you can find it too, Peter, if you, the quality, the accuracy dimension, is that it? Somebody mentioned.
That's it, thank you.
The accuracy.
That's it.
Yeah, and I'll include a link to that to the and to your book in the follow-up email as well.
University store, right?
Well,
we love it.
And, on the same long topic of data profiling, what kind of preparatory work is needed if using a tool? Is there basic functionality that is provided, like validating the format of the data matches in the field definition?
Great question. So I gave 6 classes of tools. I'm just going to go to the summary slide for them. And again, depending on what your specific challenge is, you may want to use one or more of these tool sets. So I'm not suggesting that every organization go out and buy 6 different types of tools that will fix their data quality problems. But the nature of the problem has to guide the selection of the tool. So if the problem is input, such as somebody else described earlier in an earlier question, then you probably want to look at tools that will help you get the data on the way in. Again, maybe the identity resolution or maybe enhancement type of technologies. If your data has already been captured, however, and it's pervasive throughout your system, as happens in many ERPs, then a profiling tool is more likely to be something that's useful. This is why I go back to that map that I showed up a second ago. Depending on which phase of the life cycle you're in, certain tools are going to be more or less useful. Something else too, Shannon, I think it was the data governance conference we did last year. There was a panel where they said, can we put a price on data quality? And I was amazed at the number of people who kept saying no, 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 and I kept saying yes, yes, yes. It's one of the reasons we go to these conferences, to have these wonderful exchanges, given that. Hope that answers the question.
Yeah, absolutely. Regarding deterministic matching for identity resolution, are there places to find best practices? For example, last name first, 18 of address, 1 characters, et cetera, et cetera.
I'm really surprised anybody's interested in this, but yes, this is one of the most heavily researched areas in data quality. And most of the work is coming from the University of Little Rock in Arkansas and a Professor John Talbert. If you don't know my colleague John, T-A-L-B-U-R-T. John does a great job with identity matching. I'm pretty sure if you Google identity matching and Talbert, you'll see some of his stuff come up. He's got a whole center dedicated to this process and has been working on it as really a primary focus of his research efforts for the past 5 years and has achieved some very remarkable successes there. So thanks for letting me shout John out, because he's a great guy.
And we have a couple of requests here to repeat. Who was the individual that developed the data profiling algorithms?
Dina Bitton. I mentioned I was in Boston, and several people up there said, oh, yeah, we know her. Like, well, I've never been able to find her on LinkedIn, because she has really made a significant contribution here, and we'd love to recognize her at some point for that.
Fantastic.
I think she was out of Columbia University, too, yeah.
Yeah, and how do you spell her last name?
B-I-T-T-E-N, I believe, and maybe I-N.
Okay, we'll look that up. Perfect. If you've got more questions coming in, feel free to submit them in the bottom of the Q&A. That's all for now. I think we've reached all the questions so far. I'll give everyone a second to make sure we're sorted. But it looks like it. And Peter, next month, what are we talking about? Let me look it up here. We've got
got it on our next month's slide.
Love it.
So we'll finish the year out with the 7 deadly data sins, emerging from management purgatory, and then the last one we're going to do is metadata strategies, data squared. So both of those are looking forward to speaking with all of you on this, and thanks for your participation today.
Thank you all. And oh, it looks like we have one more question if I can sneak it in here.
Okay, we're not in a hurry.
We will be looking to evaluate our organization against data quality maturity model. There seem to be a few out there. Can you recommend which one to use and a good resource that outlines the steps in how to move from one level to another?
Fantastic. Once again, my question is, you could look at any number of maturity models, but this is the only one that exists that has 20 years of research history around it. It has a record of proven better improvement processes around it, and it's an open model. So I do not recommend anybody look at anything beyond the DMM, and you can see one of those things in green is the data quality piece on that. Melanie and I do a piece on the DMM every May or so. We're going to do another one in May next year. But if you have trouble with this, if you Google DMM and CMMI, you'll see the references to this come right up, and that is definitely the direction I would go. Any other direction is really not broadly enough applied, used, or evaluated to be worthwhile when you compare it to this one. So that's my recommendation.
Yeah, and as you mentioned, you know, you've done a few webinars with Melanie Mecca from CMMI Institute to the last 2 years. So there's a link in the follow-up email for everybody for past webinars. So take a look through there. They're great webinars if you want to get more information on the DMM and just get an overview. It is a great program. So. Well, Peter, thank you so much. Again, as always, it's always a pleasure. Look forward to next month, and hope everybody can join us. And thanks to all of our attendees for being so engaged in everything we do. We just love all the great questions coming in, all the chat going on, and just all the support to help each other out. So thanks, everyone. I hope you all have a great day.
Thank you, Shannon. Thank you, everybody. We'll talk to you next month.
Sounds good.